Hello all. In this class we discuss about interfacing of 8155 IO ports with 7 segment display. Our topic is that 8155 IO ports, that is input output ports, interface with 7 segment display. Okay, so there are lots of 7 segment display available in the market, like Hewlett Packard or known as Hewlett Packard HP 5082 or 7340, and also available 9070 hex decoder and common anode 7 segment LED. Okay, so there are lots of LEDs 7 segment. So our interfacing diagram is look like that. This is 8155. Okay, from here this is PA7 to PA4, that is port A upper, and this here port signal is connected to Hewlett Packard 7 segment display. Here one attached, one 7 segment display, and these two pin are connected ground. Okay, and here we connected plus DC, and from the lower port A3 to port A0, for this port we connected another Hewlett Packard display, and these two pin are grounded. These two pin are generally known as, this is known as GN, and this is lamp test, lamp enable. These are grounded. And from PB7 to PB4, in the upper 4 white, first of all connected one Fairchild 9370 7 segment decoder, and this is 9370 decoder, and from here 8 resistors are connected, and these resistors are connected to the 7 segment display. Okay, these are common 7 segment display. These are common anode type, so connected to plus 5 volt. And here also in the lower port, that is from PB3 to PB0, here also connected 19370, and these 8 resistance is connected to this 7 segment, and this is common anode type. Okay, so here some arrangement using 3:8 decoder attached with this 8155, and the output of O4 is connected to the chip enable, and here we connected 87 to 80, these 8 pins. Here connected IO/M bar, and also connected ALE. This ALE signal coming from 8085 microprocessor to select the address or data. This is right bar, and this is the reset out. This reset out pin is coming from the microprocessor and connected to the 8155 reset. And here we apply 3 signal A13, A12 and A11, and for 3:8 decoder A14 and A15, these higher order address are connected to the enable lines, and these are 5 volt. Okay, so these are net hardware stack diagram. Okay, first of all port A upper connected to HP 7 segment display, port A lower also that. And now we find our first task today is that what is the address of this line. So first of all we write here A15, A14, A13, A12 and A11. So what is the status of A15 and A15? Both are equal to 0, because for selecting the decoder IC. Then this 3 address is apply 100, because if this 100, then this O4 output gets low, and to select this IC. Okay, so this is A11. And now what about the condition of the next display are, you know that what are the condition of A10, A9, A8, because from A7 to A0 all are connected to the 8155. Okay, so basically the remaining all are bit equal to 0. So now if we take the partition of this as a 4-digit display, so one thing should be remembered, that in the address latching in a 8155 there are basically 8 address lines, that is for used for selecting the timer, port A, port B, port C, and the control word register also. So now our task is that to determine the proper address value. So this is the address value of 2, this A15 to A12, this A12 and A11 also 0, and if we take 4-digit to represent as a hex code, then this is a value of 0010. This binary value represented by 2, and we know that for a lower address A2, A1, A0, these 3 address is 000 for control word register or status registers. Okay, this is 001 for port A, this is 010 for port B. So now what is the address? The address 20 is for CWR, 21 for port A, and 22 for port B, and so on. So the decoder logic and decoding this logic by using this is the calculation of the range of the address values. So now what are about the control word register? The control word register is a 8-bit wide. We will also know that. First of all, D7 equal to 0 because there is no effect on timer. These 2 bit are equal to 0, and these 2 bit equal to 0 because we cannot applicable here any interrupt enable facilities. So now next 2 bit, this is a port C is not being used as a handshake, and now last 1 is very important. Why? Because both input equal to 1, because both port A and port B are used as a output. So what is the code? The code is 03. So this is the code pattern of the controller register to initialize the hardware. What type? That means the uses of hardware, either input as output. So 8155 after initialize this value in the controller register, the port A can be used as output and port B can be used as output. So to configure the internal hardware, those hardware are used as an input or output. Then this controller register format determine the proper action or proper working function of the particular hardware in the 8155. So now we talk about what is our code. So now we write our code in a 8085. So first of all, we write MVI A03. This is in CWR format, which is out to CWR address, that is this. So this is called the first status register initialize, but these 2 line of code is known as CWR initialize. Then we move any data to accumulator, and this is out to 21. What is the advantage of out 21? That is, this is a port A, so 21 is a port A address, so this data is moved to the port A. Okay, and now if we again, this is another data 2, say data 1, and out 22, so this data is moved to port B. Okay, and if we jump here, so the program will be in a loop, so it will be continuous infinite times, because jump is an unconditional instruction. Okay, so using this jump in loop, we loop in the program, and the display will be shown the proper port A, show the data 1 in a port A, we show the data 1, and through port B we show the data 2. So depending on the various data, we can show here one data here, one data at this display, and another data in this display. So this is the technique how, and there should be remembered that here we use IO read bar and IO write bar signal from the microprocessor. Okay, they connect the IO read bar and IO write bar from the control signal of 8085 from the 8085. So that's why this is the process. Okay, this is the process to design the hardware description and interfacing the 7-segment display. Using this 7-segment display, you also design the counter or any kind of value is showing, or to display the any applications or project. Okay, so this is the process. So what is the algorithm? First of all, we draw the hardware. This is step number 1. Then we connected the address logic and connected all pins from the microprocessor, and then we decode the logic as per internal hardware requirement of the 8155. These here I again mentioned that these 3 lower address line are used to select the proper control lines. That means port A, port B, port C control register, or time array, LSB or MSB. So different types of code here. A2 from A2 to A0 are selected, the different types of action needed in 8155. And to select these IC here, this A15 is A14 equal to 00, and A13, A12 and A11 equal to 100, because this O4 output is selected. So that's why we write here. So from here we get 2, and the lower address equal to 000. So this is coming from the address of first of 20, then 21, then this is 22 for port B. Okay, so that's why we generate the address for specific port. And now this is our CWR format. This is our CWR format, which is 8-bit from D7 to D0. Okay, this D6, D5 is basically used, no effect on timer. Then these two are not applicable because there is no interrupt. This is related for port C. There is no change in port C are used for using handshake, because here we just simple in this program we just simple the data transfer to port A and port B. So there is no handshake concept are used, and these two ones are coming because port A and port B both are used as an output. So if this port A and port B are used as output, then here we put the logic 1, and after this is our code, simple code to written in 8085, and after running this application it will be show the data in these two 7-segment display. So this is the 8155 application using IO map, using IO interfacing. That means all data from the microprocessor are coming in the 87 to 80 bus and then goes to the corresponding port. So that's why it is known as simple input output mode operation, because you already know that in a 8155 there are lots of operations are performed. That's why it is known as multi-purpose. This 8155 is basically known as multi-purpose programmable chip, and one use the 256 byte of read memory, and then the timer function, and also the programmable the IO functionality is also available in these 8155 IC chips, peripheral IC chips. Okay, and one thing should be remembered, that first of all there is some algorithm or steps by which we can communicate with the peripherals through the 8155, and the following two steps are: number 1, please note that first of all determine the address, that means port address of the registers and IOs based on the chip enable logic and address line 80, 81 and 82, because you know that 80, 81 and 82, because 80, 81 and 82, these three address line are basically used for different purposes action in the 8155 IC chip. Then number 2 is that write a control word in the control register to specify the input function of the port and the timer characteristics. Number 3 is that write IO instruction to port address to communicate with peripherals. And number 4 is very important: read the status register if necessary to verify the status of the IO port and the timer In a simple application, this step is not requirement. All, all, all the this is not the very important step for all hardware purposes. Some specific application, the read of the status registers is very important to show the status of the different IO ports. Okay.